Good morning, myself Krishna. And to recap my previous video, in machine learning, we are going to have two branch, one for supervised, another for unsupervised learning. Supervised is going to work on labeled dataset, unsupervised will work on unlabeled dataset. In supervised, we have two branches, one for classification and another for regression. Unsupervised, again, we are going to have two branches, one for clustering, another for association. So I will talk in detail here. So when we say label data, so in the label data, you are going to have the features and target. Just think this is the label data. These are the feature and target will be the outcome. So if your outcome is like here outcome we are expecting in binary, yeah, Boolean result set like based on this data we are saying whether this patient is diabetes, yeah, it is non-diabetes patient. So here outcome we are expecting in binary format. So when we expect outcome in binary format, that will go under classification. So this is for the label dataset. So classification is supervised learning, which work on label dataset. Unlabeled dataset, you can have the data and you are trying to find some pattern. Like for this dataset, if you need to detect group the customer based on annual income, yeah, spending score. So some patterns you when your model is trying to find out that we call unlabeled dataset. So here we don't have any feature, any target. You are just training your model to find appropriate pattern. So for the classification, like I said, outcome will be the binary Boolean. And algorithm, we can exercise either logistic regression, decision tree, random forest, SVM, neural network. When your data set is larger, you can go with neural network. But for most, yeah, I mean, what I experience, random forest used to provide the result with higher accuracy. So mostly people used to prefer using random forest. Decision tree we people use on a small set of data, but here this outcome is not come with higher accuracy. So like here you can say this is the data set. So in this data set, this will be feature and this is target. So all we are trying to find out whether this is heart disease patient or not. In the regression, our outcome will be a continuous value. It could be number or discrete. So algorithm we use for regression is linear regression, decision tree, random forest, SVR, yeah, support VAC vector mag machine, neural network. So here, like it is given a square feet, number of bed, age, and price. And if you need to predict 2000, I mean 2500 for new data set, what could be the price? You can train your model based on the following algorithm, and you can predict your data. Clustering, like said, it is part of unsupervised learning, which always trying to find the pattern. It is not going to have any feature or any targets. An expected outcome is set up cluster or group. So generally, most famous algorithm cluster for this clustering is k-mean clustering and hierarchical clustering. So coming to association, association is trying to find out the relationship between two data point, and it is going to propose, yeah, it is going to suggest uh, uh, the outcome. Like if you, uh, if we know, like over Netflix, we can see some suggestion. Like over the year, if we are watching some movie, this pattern is trying to find out a like-minded customer, and if something I didn't watch, some other people has watched, they are going to give us this suggestion. So for this one, we use a priori algorithm, ECLAT, epic growth. So here you can see like five transaction happened. First transaction bread milk, second transaction bread diaper beer egg, third milk diaper beer cola, fourth bread milk diaper beer, and fifth one bread milk diaper cola. So the guy who did transaction bread milk, you can see diaper is in why diaper is in all the transactions. So he will get suggestion for diaper. So this is how this algorithm will work. Now coming to workflow of machine learning project. So in the workflow, we are going to have data set, data pre-processing, data analysis, train, test, split, machine learning model evaluation. So these are the workflow for machine learning. So in the data set, data set is all about getting data from various different sources. It could be the database, data lake, yeah, any in system, a cloud system. You are getting data and data pre-processing and data analysis. This is data engineering job where once you get the data, you are trying to do the analysis whether data is appropriate for your model or not. And if anything is missing, you are trying to fill the data. If there is any input, I mean missing value, you can try to visualize. Sometimes we need to visualize like how this data is there, whether it is giving linear um, uh, like when you plot you can see whether you are getting linear outcome, yeah, skew outcome, and then you decide to whether you can fill the data through mean, yeah, through a standard deviation, yeah, median. So we have some maths here which I will be talking. So in the data imputation, you are trying to find mean, median, mode to filling those empty value. And if you didn't find anything, at last you can drop as well. And because if data is null, it won't be helping uh, to to prepare your model. So when we call mean will have sum up, like if this is the list of item 1, 2, 3, 4, 5, so it will be sum of all the item slash number of items. So you can say this will be 3. Medium, it is going to hold the middle value. So first you can arrange your list of item like I arrange, and here you can say we got 2 item in the middle, so you can take main for those 2 item. Mode is trying to look the repetitive, like here there is no repetition, so there is no mode for this one. Here you can see there is a repetition. So 1, 2, 2, 3, 4, so 2 is the mode here. And here you can see we have 1, 1 repeats, 2, 2 repeats, 3, 3 repeats, so mode are 1, 2, 3. What is train test split? So in the train test split, what we used to do, just think this is the data for the diabetes patient. And in this data set, just think we have total 20 data. So in train test split, what we are doing, we are we are splitting the data into the training and test data. So what we are doing, we are splitting in two chunk. One is 80%. Just think this is the 80% data, and this data we are keeping for training our model, and remaining 4 records we are keeping for testing the model. So eventually, when we talk about model, you are trying to find out best equation, and once your equation is derived, you can use this data to see after giving those feature what we are getting, what is accuracy of my model. So this is the actual data set we are keeping for testing our model. So when we say train test split, it means whatever data set we have, we are splitting into the ratio for our training and test model. So generally 80% we are keeping for training and 20% we are keeping for test model. This is called train test model here. Okay, this demo I will come later. Before that, I have one more thing to come, standard deviation. So a standard deviation, you can say this function is uh, for getting the standardized value. So here, this is the actual value minus mu, mean, and this is called population density, if you can say. So population density is total number of item 1 to n. Xi means actual minus x mean, um, predicted one. So just to give you example, this we generally use. Actually, what happened when you are getting this data set, sometimes we need to standardize. And why we need to standardize? Because we don't know the unit of this data set. We can have different unit. So when we are uh, we are going to train the model, we can have different scale. So what we used to do, we can standardize our data, and to standardize our data, we are using this formula here. So just think, if we already have predefined function you can use to standardize your data. So here you can see this is my data, where we have height and weight. This is my data frame, and this is the client for data standardization. And here we are using a scale, this client dot fit transformation. This data frame I'm supplying to this standardized data. Eventually, I'm going to get this height weight like this. And how this is calculated? So this calculation happened based on this one. So if you see this standardization is equal to actual minus mean by population density. So first you can take the mean here. Mean means you are going to um, sum all the data. Just I'm explaining how this has calculated. Like that you can uh, like that we will have other calculation. So for the mean, you can um, take sum of all the records slash number of record, it will come 170. Similarly, you can take a standard deviation. So a standard deviation is equal to 1 by total number of item. This is summation of I is equal to 1 to n xi actual minus uh, uh, mean. Yeah. So here you can see 150 minus 170 is the mean we calculated. Xi minus um, x mean here. So 150 minus 170 square, 160, 170, 170 minus 170. If you see the mean here, square root of 200, it will come 14.41, right? So now we got here, we got mean, we got a standard deviation, and now we already have the actual value. Now we can calculate this standardized I mean, standardized form of data. So Z is equal to 150. Just think, if we are talking about this one, 150 minus 170. 170 is mean, and slash st 114.41. So it will come this one. So like that, it has calculated all other value. So for this video, we have this one. I will try to explain how we can do this thing uh, in Python in my next video. So thank you. I will be catching tomorrow. Bye bye.